All right, so welcome and well, thanks for having me here, and welcome to my session about Kafka and Spring. So my name is Sergi Almar. I'm a software engineer, and I'm also delivering the trainings, Spring trainings for Pivotal, so all the official trainings, and also recently this year I joined Confluent, right, which is the company, right, supporting Kafka and providing trainings as an instructor as well, right? So I'm basically delivering trainings half of my time, right, whether Spring or Kafka trainings. And I'm also the Spring I/O conference organizer. Anyone heard about the Spring I/O, the conference? Some of you? All right, so it's basically the biggest conference in Europe for Spring, right? So basically, if you know, or if you want to know more about Spring, that's the place to be. All right, so today we're going to talk a lot about Kafka and Spring, how to combine them together. So just a quick show of hands, how many of you use Spring here? All of you, that's great. How many of you use Kafka here? A bunch of you. All right, and how many of you have been to Tim's talk? So basically a talk that was before mine. Some of you. All right, so some of you already have a good understanding about Kafka. We're not going to spend a lot of time talking about Kafka or the architecture or the internals, but we're going to spend more time right in the integration between Kafka and Spring. All right, so just so we are all on the same page, we're going to well, basically recap a little bit or revisit some of the important topics in Kafka, right? So at the end of the day, Kafka is a distributed log, right? So everything is basically, right, or we're going to deal with records or messages, and as you have in the application logs, right? So everything is append only. So everything that you send into Kafka will be sent into a topic, right? And these topics will be append only. So everything that you send into the topic is immutable. That means that you cannot change it. You send a record or send a message, and that's going to be added at the end of the log. So every single message will have an offset, right? And so that's how we identify those messages. And as we see here, we can have producers and consumers running at the same time, but producers will basically send at the end of the log, and consumers will basically read from anywhere in the log, right? So when they start, they may start reading from the beginning of the log, and they will read sequentially, right, until the end of the log. Or they might decide to basically start from the end of the log and just process the new records, right? So the number of the message is called an offset, right? So we're going to have a log which contains messages, and we're going to have offsets for every single message. But internally, a topic can be partitioned, right? And that's how we achieve or how we scale, right, from the producer and also the consumer side. So imagine that you have multiple brokers in your cluster, in your Kafka cluster. You can actually partition your data, right, based on partitions, right, that you can define at a topic level. So when you create a topic, you basically define how many partitions you want for that topic, and the number of partitions will determine how many consumers at the end of the day you can have. So it will determine the level of scalability you can have in Kafka, right? So, because you cannot go beyond the number of partitions. So that's a way to scale. So we're going to partition the data. So when you send a message into Kafka, that message can fall into the partition 0, 1, 2, as we see here. And actually the producer decides where to store that particular message or where to send that particular message. So a default strategy to determine whether, or the partition to send the message to, is to basically hash the key of the message and do modulus and the number of partitions if we have a key for the message. If we have keyless messages, which are basically messages without keys, then we're going to do it in a round robin, right? So we're going to send a message to every single partition. So that means that partitions have a subset of the data inside a topic, and that's where we guarantee the ordering. So we cannot guarantee the ordering at the topic level, but we can guarantee the ordering at the partition level, right? So we're going to write in any of these partitions, and as said, that's going to be an append only thing. So we're going to add the message at the end of the partitions. So that's basically how a topic is structured, right? And internally, a topic is also broken down into segments, right? So on disk, we're not going to store everything into a single file, but we're going to break it down into segments. Those segments have by default a size of 1 gig. So every gig we're going to basically create a new segment, and the active segment is basically the one that we're using currently or sending or appending messages into. The other ones will be the old segments, which will be used for reading only, right? And that's basically how a topic is structured. A topic is broken down into multiple partitions, and a partition will have, at the end of the day, multiple segments. All right, so if you take a look at the APIs that we have available in Kafka, we have the basic producer and consumer APIs. So these are the low-level APIs that allow you to basically produce messages into Kafka, consume messages from Kafka. That's, again, right, a really low level. Doesn't provide much, just sending and receiving messages. But then we have another API, which is the Streams API, which we're going to talk a lot about it in this session. So the Streams API is basically what allowed you to transform the data, right, easily by providing a DSL. Right? So it's going to be quite straightforward to basically transform the data, right, and basically process the data. And we're going to talk a lot about streams here. Then we have the Connect API. So Kafka Connect is basically a framework that allows you to interact with the outside world. So at the end of the day, we are not alone in this world. So we might live with databases or Elasticsearch and many other different systems. So Connect will basically allow you to integrate, right, with all these different systems. And the last thing we're going to see, or that we have, is the admin client. The admin client is basically an API which allows you to interact with the broker, maybe to get some information about the cluster, maybe to create topics itself, right? So it's basically more administration. So Apache Kafka Connect is basically a really important part, right? Because as I said, in Kafka you'll be processing the data. So you'll basically process the data that you have in Kafka, but how do you bring the data into Kafka? Well, we have different ways to do it. So one is using the producer and consumer API, which is, quite straightforward. But if you already have an existing system, maybe a legacy system that has its own database, how do you bring the data into your Kafka so you can process the data? Well, one way is to use Kafka Connect. And Kafka Connect, as mentioned, right, is this framework that allows you to integrate with the outside world. And we have a lot of connectors. So inside the framework, actually on top of the framework, we have connector implementations. Some of them are open source, some of them might be commercial, but that's actually the easiest way to basically get data from the outside world into Kafka, or to basically take data from Kafka into the outside world. So we see here in this slide, right, that we have a lot of connectors, right? And basically those are, or most of them are open source for the traditional use cases, like moving data from a database into Kafka, moving data from Kafka into Elasticsearch. These kind of things are already implemented. So Kafka Connect provides a fault-tolerant, right, a reliable, right, a way to do this data movement without having to write any single line of code. Right? So at the end of the day, right, if you write your own implementation, you might introduce bugs, you might not take into account the edge cases. So actually, this is the easiest way to bring data into Kafka and basically send the data outside from Kafka. All right, so we have actually these 5 different APIs in Kafka, but what do we have in Spring, right? So this session is more about the Spring integration, how we use, right, Kafka into Spring. Actually, we have a lot of support in Spring. So we have a project called Spring Kafka, and Spring Kafka it's basically wrapping the producer and consumer API. It's basically making everything Spring friendly, right? So you basically stick to the same programming model, the one that you already know, right? It also supports Kafka streams, right? We're going to talk about that later on. Then we have a Spring integration. Spring integration also supports or has support for Kafka. It provides inbound and outbound adapters. It provides gateways as well. Another project that has support for Kafka is Spring Cloud Streams, and we're going to spend most of our time, right, in talking about the Spring Cloud Streams in here, right, to basically process, right, or to build these real-time data pipelines. So we have support again for Kafka and Kafka Streams. Then we have a Spring Cloud Function, which is one of the newest projects, right? So maybe it's about a couple of years now, but it allows you to basically implement, right, functions, right, like traditional Java functions, right, and basically use those as processors, right, of your streams. We have also Reactor Kafka, right? So basically part of the Reactor project that allows you to implement, right, or producers and consumers, right, in a reactive way. So if you want to interact with other systems, maybe you're doing some HTTP requests, right? So going for Reactor Kafka might be a good thing. So we have everything non-blocking, right? So you can integrate with flags, monos, right? All the reactive types that we know, right, from the Reactor project. And also recently we got some support on a Spring batch, right? So Spring batch is basically used to implement batch jobs, right? And a Kafka, even if it's a streaming platform, and we use usually Kafka for streaming data, right? We can also use that for batching, right? And basically to send data from the batch jobs into Kafka, or ingest data, right, from Kafka. So we have different readers and writers that can support Kafka as well, right? So that's a nice addition, right, into the portfolio as well. All right, so let's talk about Spring Kafka, right? So which is the first project that we have been talking about. So Spring Kafka allows you to basically send and receive messages in a Spring-friendly way, right? And I guess that you're familiar with some of the templates, like the REST template, the JMS template, the RabbitMQ template, right? So if you have been using Spring for some time, you might have used some of the templates, right? So Spring Kafka provides a Kafka template, so you can send, receive, or basically send messages, right, in the same way as you do it with the JMS template or the Rabbit template. So here we have an example, right? So template.send, we specify the template, the topic name, the key and the value, and basically that will return a listenable feature. So that's a completely async call. So you can define a callback for success and failure as well. That's optional, right? But you can actually get the result of that sending into Kafka. So we support basically the async and sync as well, sending of messages. In order to consume messages or receive messages, we have a listener, right, that's available with the @Kafka listener annotation. And so at the end of the day, we are going to have a listener container that will manage our Kafka listeners. And Kafka listener is nothing more than a passive component that will receive, right, messages from Kafka as they come. So in this example here, right, we see well, that's basically. Where's my mouse? Wow. In the first example here, we basically see a simple method annotated with a Kafka listener, and we basically specify the topics we want to consume from. So every single message that comes in will be delegated into that particular message. So as any other listener in Spring, so if you have been using any other messaging systems like Rabbit or JMS, we have really flexible signatures. So we support injecting or passing the payload. We support using the @header annotation to get some of the headers. So we have really flexible signatures to basically get anything from the messages, which is quite nice, right? And that's basically how, right, we consume messages with Spring Kafka. Of course, well, it basically supports or has a lot of configuration, which is not shown here. Like if you want to read from a specific partition, you can do that. If you want to manually commit commit the X, you can actually do that as well. So it's completely flexible, right, in the way you process those messages. And then we have also, right, a way to configure topics, right? We have actually support for that. So if you register any bean in the application context, which is a type new topic, this is going to be auto-created, right, in the broker as well. So we have a builder, the topic builder, that allows you to create those topics. Like in this example, we create a topic with a couple of partitions, one replica, and we basically make it a compacted topic, right? So not a delete policy, but a compact policy. The second example, we are passing some configurations to the topic as well. So we're basically defining the compression type to Z standard, which is a compression algorithm from Facebook, quite efficient. So we're basically building that topic, and we're just exposing that as a bean. And if you do that internally, that's going to be created into Kafka by using the Kafka admin API, right? So if you use a Spring Boot, Kafka admin will be created for you, right? And all these topics will be created without, right, having to explicitly create them, right, yourself. Right, so let's take a look at a quick demo, right? And actually have some demos in this presentation. And I just built kind of a shopping or an e-commerce site, right? So let's take a look at this. So that's going to be a Spring Boot application. Can you see that from the back? Should I increase the font? No? Right, great. Right, so I have a normal Spring Boot application, and if we take a look at the build.gradle, we have some of the dependencies, right, from Kafka, right, and that's basically how we bring in, right. So we're gonna take a look at this one here, Spring Framework Kafka. So basically bring in all the Kafka dependencies, and just because we're using Spring Boot, the Spring Boot will do a lot of auto configuration. So we take a look at our configuration file. We're just providing some of the configuration that usually if you use a Spring, if you use Kafka, you should define in code. So usually when you create a producer, you define the properties in a property object and you pass that into the producer. As we're using a Spring here, we're going to basically put all the configuration into our application.yaml or application.properties, whatever you have, and we're basically specifying a property called Bootstrap Service. So that's basically going to point to our broker. So we have it in localhost 9092, and then we have a couple of configurations to define the serializers. Actually, Kafka doesn't understand about objects, so it basically understands about bits and bytes, right? So that's everything that we do, right, at that broker level. So when you want to send a message, if you're dealing with an object, you have to take the message and serialize it somehow, right? So we have different ways or different serialization algorithms, the key serializer and the value serializer are basically the ones that will do this job. They will take whatever you have in the key of the message and they will serialize it into bits and bytes, and we're going to do the same thing for the value. So everything that you send into Kafka are messages which have key value pairs, right? So that's basically a message in Kafka. The key is optional, right? But usually we have key value pairs. So we're going to take the key, pass it to the serializer, convert it into bits and bytes. We're going to do the same thing, right, for the value, and we're going to send these bits and bytes into the broker. The broker stores that, and the consumer is going to do the reverse operation. So it's going to deserialize the bits and bytes, the key and the value as well. So that's why we specify these two guys in here. So in our case, the key serializer is a string serializer, and the value serializer is a JSON serializer, which basically comes from the Spring support. So we want to serialize everything in JSON. All right, so before going into producing, right, messages, let's take a look at the configuration. I have a couple of bins here, right, which will create our topics. So we have one topic which is called a page view. So that's the page view topic. So we're going to define a couple of partitions, right, for that, because we want to maybe scale at some point in the future. And then we have another topic called product. Actually, we're not going to use that currently, right? But it's actually defined as a compacted topic, right? So that will be another topic which will be created in our broker. So that's basically part of the administration part, right? So the admin client will take care of those and we'll create those on Kafka. And what I've done is basically to create a simple controller. Let me just quickly start the application so you can see it and see how it looks like. All right, so let me just check that it's running. All right, so I have a really simple page, right? So which is an e-commerce site where we can buy a bunch of stuff. We can buy some electronics, we can buy some books as well, we can buy some clothing, right? And well, this application is not doing much, right? So the main intention of the application is to basically track the user activity. And in order to do that, we're going to track every single click that the user does, right, on the website. So we then can analyze those page views, and we can basically aggregate and do some analytics on those page views. So it's basically not doing much, and actually when you click one of these links, it's returning to the same page. So for the sake of simplicity, so you can see that well, in our controller, we are basically injecting the Kafka template. So this Kafka template is created by Spring Boot. We don't have it in the just because we are using Spring Boot, this Kafka template will be created for us, so we can use it, right, in our application. So we're basically injecting the Kafka template, and that's what we're going to use, right, to produce messages into Kafka. Then we have a handler method, which is going to handle any request to /product, /category ID, /product ID. So we go back to the e-commerce site. So we take a look at well, maybe you don't see it, but well, basically when you click one of these links, it will go to /product, /the ID of the category, /the ID of the product. So we're basically going to reach this method, and in this method we're basically getting the product ID from the URL, the category ID from the URL. We're also getting the user agent, so we know the browser, right, or basically the client that is consuming that URL, and we're going to basically take the request URI, so we can basically store that page view, and we store all the information. So you have a class which I created, right, called page view, which will basically contain all the information we need, right, for that page view. And so I'm using Lombok for simplicity, but we basically have a timestamp, so that's basically when we have clicked that link, the user agent, the product ID, category ID, and the URL. So we basically want to get all this information and send it into Kafka, and that's going to be our front-end application. Right? So we have one front-end application which displays all the products, and the other thing that we'll do is to take all this information and sending it back to Kafka. So in here we see, right, this Kafka template.send. So the first parameter here is the topic. So we have a topic called page view, which we have actually created in here. So that's basically the topic that we have just created. It's a topic with a couple of partitions. And we are basically setting the key value pair. The key will be the product ID, whereas the view, right, so what we have built, so this object here will be our value, right? So the value is basically serialized as JSON, right? And that's what we're going to send into Kafka. All right, so let's quickly start this consumer. Actually, this is the Kafka console consumer, right? So really simple command line tool to basically get or consume messages from a specific topic. Our topic is called page views, right? So I'm going to views, page view. I'm going to start the consumer. Of course, the consumer will basically start consuming, right, as long as we get messages into the broker. So now it's time to go to our site and basically start clicking these URLs. So again, the site is not doing much, it's basically returning to the same page. But as you see here, if we go back to the console producer, we got some records. Actually, we got 3 records because we got 3 clicks, and this is, this is one record, the first one here. Right, so notice that it's basically showing the product 2, the category 1, and this is the URL, product 1, 2. So we have actually a second product and a third product. So we can start or keep on clicking like the red dress, and we'll see yet another product coming into the broker. Right, so that's basically the way to send messages into Kafka, the easiest way to send messages into Kafka. All right, so now, well, you might have another microservice which takes care of this data and processes this data. At the end of the day, we want to build real-time data pipelines, right? So our front end will basically send this information into Kafka, and it's not going to do much, right? So basically send it into Kafka, and Kafka will be right where we store those messages, and someone else can come and process those messages. So I have yet another application, which is the this one here, which will read right from Kafka. So again, well, in the application.yaml, we have some configuration here. So now we're going to have configuration for the consumer. Before we had it for the producer, now we're going to have it for the consumer, because as I said, the consumer needs to basically deserialize the data. So instead of serializers, we're going to configure now deserializers, which will deserialize the keys and the values. So if we go back to the application, we'll start real simple, right? And well, let's take the first example, and let's see how we can create a listener or a consumer for that particular topic. So we have created a Kafka listener, or it's basically a method which is annotated with Kafka listener, and we're specifying the topics that we want to read from, right? So that's going to be a page view. And notice the signature here. We're basically passing something called the consumer record. Actually, as said, this signature can be really flexible. So you can pass the whole consumer record. So that's basically identifying the record, so key value pairs. So that's basically my key string, and the page view is what we're expecting. So we're going to take JSON and basically map it into the page view. Or you could actually pass the page view directly, which is the value, right? So we could also get some independent headers, so the signature is quite flexible. So with this application, let's start it. So let's start the reader here. And notice that the reader is not doing much. It's not even processing the record, right? So it's basically printing everything into the console. So notice how just by starting the consumer, we got a bunch of records. Actually, those are the records that we had before in Kafka. Well, let's just see what happens when we have new interactions with our website, right? So when we start clicking here, right? So basically, the front end was sending these messages into Kafka. And then we have the second microservice, which basically took those messages and processed those messages. So we see down here the 3 clicks we have done, right? So we see here that, well, this is the topic page view. Some of the messages ended up into the partition 1, some of them ended up in the partition 2, and then we see the keys, the values. Right? So basically, we have control over everything, right? That comes into Kafka. All right, so that's a really straightforward listener, right? But what if I want to do something more complex, right? So usually you want to process all this data, right? And what we're going to do now is to try to aggregate the data, right, that we get from Kafka. So what we're going to do is to aggregate the data based on categories. I want to know how many clicks we got per category. Of course, you can implement that, right, with a simple Kafka listener, but we're going to see the drawbacks of that, right? But well, let's go step by step. Actually, I missed that. So I have just created it's actually here, a map, right, that will basically have the category and the number of clicks that have been produced for that category. So when we got a message, we're going to basically check if we have this category or not. If not, I'm going to initialize the category to 0, and then I'm going to increment the category by 1. So I've created a simple POJ here, which is called category count, and we're going to store the category ID and the count, and that's what we're going to send back into Kafka. Notice that this signature is actually returning something, a category count. So whatever you return from a Kafka listener can be sent to another Kafka topic, and that's what we do with the send to annotation. So we're going to get records from the page view topic, and we're going to send, or actually receive messages from the page view topic. We're going to send messages back into Kafka to the page aggregate. So if we run this, hopefully we're going to get some data into the page aggregate topic. So let's go back to our console and let's start yet another consumer and see what this produces. All right, so let me just restart the reader because we have changed our listener. All right, and let's start interacting again with this. I want to buy a book as well, an address for me, right, and yet another book. Let's go back to the console. So as we see here, right, so we got a count, right, on every single category. So category 1 gets the count to 1, category 2 gets the count to 1, category 3 gets the count to 1, and just because I clicked again category 2, I get a count of 2, right? So notice that every time we increment the counter, we get a record, right, all the time, right? So just let's make this smaller. So when I click here, we see here that the category 1 is keeps on increasing the count. But implementing this kind of aggregates yourself is quite hard, because what happens if my application fails, for instance? Let's imagine that, well, my application stops. I stop my application and I restart it again. And now I'm interacting with the site. So as you see, down here, right, the state is not maintained. So the count comes back to the initial state, right? So our application is not fault tolerant, because if there's any failure, right, so that state is lost, right? And that's usually, well, you should be fault tolerant, right? Because especially when you want to scale up and down, you don't want to lose this state, right? So implementing this kind of a stateful aggregation is really hard if you want to do it yourself. And that's why we're going to look into Kafka Streams, which will give you that for free, right? So it's basically going to provide all this stateful processing, right, out of the box, and it's going to be fault tolerant, so we can recover from failures, right? So that's going to be a better way to process or to implement these data pipelines. All right, so let's get back into the presentation. Actually, well, we're going to do some stream processing, right? And in the stream, we're going to get, or a stream is basically this unbounded and continuous real-time flow of records. And here, the unbounded word is really important. That means that it's endless. We don't have an end. So when we do stream processing, we're basically processing records as they come, and we're basically processing them once at a time. We're not, right? We're not waiting until the end, right? So we're basically getting messages all the time, these key value pairs, right? And at the end of the day, right, we have like new requirements, right, in the new applications. So we basically need to process the data in real time. And we have a lot of use cases, right? So for instance, so real-time fraud detection, or if you want to fit some machine learning models, or if you want to apply some transformation in real time as well. So we have actually a lot of use cases that require some real-time processing, right? So batch processing is still a thing, right? And we might need it, but we actually need a lot of real-time processing in the modern application. So we can use Kafka as the event streaming backbone, right? So in order to take those events and process those events, so you can send them the result into maybe some other applications, or maybe, I don't know, some other data stores, right? So we're going to use Kafka as our main event streaming platform. So one of the APIs that Kafka provides is Kafka Streams, right? Which gives you a really powerful way to process those messages, and it's basically built on top of the consumer and producer API. And actually, we have another API called the processor API, really low level, right? And it provides a DSL on top of that. So it allows you to provide or to define stateful and stateless transformations. We're going to see that in a second. And also, it will allow you to be elastic, scalable, fault tolerant, so you can increment the number of processors, right? And basically recover from failures. So it's actually pretty nice. A couple of building blocks on the Kafka streams are the K-stream and the K-table. A K-stream is nothing more than a representation or an abstraction of a record stream, right? So basically, every single message, right, in the log, right, basically in Kafka, will become, right, a message in our stream. Whereas a K-table is seen as a change log, right? So if we compare that to databases, for instance, a K-stream would be an insert, right? So every time we insert, we basically get a new row in a database, right? So in here, we're going to get a new event, right, all the time in the K-stream. Whereas a K-table could be seen as an abstract, right? So where, well, if we send a record and it doesn't exist, right, with that particular key, we're going to have it. Otherwise, we're going to update, right, the record. Actually, a K-table is a representation of the latest value of a particular key, right? And that's why, well, we see that the K-stream it can be seen as the history, right, of the messages, and the K-table is like a snapshot, right, of the values at a particular time, right? So it's basically maintaining just the latest version of a particular key. So these are the building blocks, right? And it's important to understand what a K-stream and a K-table is, right? And we'll be building a topology. A topology is nothing more than what we need to do, right, in our streaming application. So we have source processors, sync processors, and stream processors. A source processor is basically the one that gets data into the topology. Then we have the stream processors, which are basically applied transformations into the stream, maybe map, filter. Then we have a sync processor, which is the the processor that will take data back into Kafka. So usually what we do is to get data from Kafka, process the data, and sending it back into Kafka. So if we take a look at that stateless operations we can use, right, from the Kafka Streams API, we have filter, map, flat map. Actually, if you're using or have used like Scala, you might be familiar with a lot of these methods, or if you have been using the collection API, right, in Java, you might be familiar with those messages as well. But well, basically filter will basically downstream the event or the record if we match this predicate. Map will basically convert a key value pair into another key value pair. Map values is actually the same, but only mapping the value without the key. And flat map is usually when you want to create from a record multiple records, right? So you can produce 0 or more records at the end of the day. I'm going to go quite fast here because I want to reach the demo and we don't have a lot of time, so we're going to see that in the demo anyway. And then we have some stateful operations, and the stateful operations are usually the ones that aggregate, right, and basically do some aggregation with the data. And for that, we need to have a state store. So Kafka Streams is using something called RocksDB. RocksDB is a key value store which is going to be embedded into the topology, right? So every time that you do an aggregation or a count or you reduce something, we're going to store the result or keep the state into the state store, right? And by default, the state store is the RocksDB database. You can change that. You can use an in-memory state store. You can implement your own state store, but by default, that state store will be in memory, right, in RocksDB. Actually, that state is synchronized with Kafka. Actually, we are synchronizing the state store in a topic in Kafka because if we fail, right, we want to recover all the state. So we're going to keep it in memory to be fast, but we're going to basically replicate that into Kafka just in case we are failing. So at the end of the day, this is the architecture we're going to have. We're going to have some source topics. We're going to have a stream application, which will have underneath a consumer and a producer. And every single partition in a topic that we are processing will translate into a task. Every task will run the whole topology, and it will have its own state store. Right? So every single task will process part of the stream, right? So based on the partitions, and actually, if you have used Kafka and the consumer groups, that's basically how the data is distributed as well. So we're going to consume from Kafka, we're going to go through all the topology, and at the end of the day, we're going to send the data back into Kafka. Well, that's not mandatory, right? But that's usually how we do it. We take data from Kafka, we basically go through all the topology, and then we store data back into Kafka. So another good thing or nice thing that we can do, right, is windowing, right? And windowing allows you to basically process the data in a windowed fashion. Maybe you want to aggregate the data. Let's say I want to count the number of clicks that I got on this particular product, but I want to get it every hour, right? So I want to get the number of clicks per hour, not the aggregate for the all time, but just for every single hour. So you can define a tumbling window, right? So this is basically a window that will start, will end, and then we're going to start a new window. So we can basically compute or aggregate events on that particular window. Then we have another option, which is the hopping window, which is going to, or that's also called a sliding window. We're going to create a new window based on a property called advanced by. So some of the records might fall into 2 different windows, or 3 or 4, right? So depending on how they overlap. So these 2 are time-based windows, whereas the last one, which is the session, is more an activity-based window, right? So we're going to get records, right? And a session is identified by those records plus an idle time. So when this idle time has passed, we're going to basically close that particular session. So sessions don't have to be of the same time. They can be of different times. Right? We're going to see that in a second. We have also joins, right? So if you want to basically enrich some data, right? Joins is basically the way to go, right? So we have support for inner joins, left joins, right? And outer joins. And the only requirement here for joins is that the data needs to be co-partitioned. And that means that if you're joining 2 streams, both the streams need to have the same keys, the same type, and also they should have the same number of partitions. So you can join a case stream to a case stream, a K table into K table, a K stream into K table, right? So we have those joins supported. So when you join, you basically join one stream to another one, and then you provide something called the joiner, right? So basically a method that will join both streams. We're gonna see that as well in a second. We have also support for branching, right? So branching will basically create a bunch of streams based on one stream, and you can do that by defining predicates. So if a record matches a particular predicate, well, it's going to be sent to one particular topic. If it matches another predicate, it will be sent into another topic. That brings me into Spring Cloud Streams, and this is what we're going to see in the demo right now. So Spring Cloud Streams is basically what allows you to implement these highly scalable event-driven microservices. And we have a couple of concepts, which are the binders and the bindings. And the binders is basically what provide the integration between your application and the messaging system. We have a bunch of binders, and the bindings are basically how, right? We are basically bridging, right, this integration between the application and the messaging system. So that's basically how it works. We have our application with the Spring Cloud Streams, with the Spring Boot. We're going to have a binder that will basically simplify, right, the integration with the messaging system. That could be Kafka, but that could be also RabbitMQ or maybe Amazon Kinesis or any other supported. And we're going to basically feed data into the binder and get data from the binder. So it just went real quick, right? Because I want to move into the demo, which is more interesting. And we have here the demo for Spring Cloud Stream. That's a really simple boot application, but we are going to replace the consumer that we had, right, by another consumer. I'm going to go straight into the streaming API, right? So I'm going to just Kafka stream processor. Let me just change that. I'm going to bring in the first example. All right. So this is basically how the streaming API looks like combined with the Spring Cloud Streams. So notice that we have now a new annotation called a stream listener. Right? So a stream listener will basically get data, right, from a particular binding, and this binding is called input. If we take a look at this annotation called enable binding, let's get into it. So we have something called input, and that's basically the input binding. So this input binding is going to be configured in my application.yaml. So if we take a look at the application.yaml real quick, application.yaml, you'll see that we have here the bindings in here. And we're specifying that the input binding is actually going to a destination called page views. So that means that whenever I say I want to read from the input, and that's actually a message channel at the end of the day, we're going to bring in data from the page view topic, which is what we have produced from the front end. All right, so notice that what we're getting as a parameter is a case stream. So this is basically representing the records in the stream, in the change log. We are having the key and the value. So notice that when we get this stream, we can actually apply transformations. And in our case, we want to count the number of clicks per category. So the first thing I'll do is to group the data by the category, because we want to aggregate the data by the category. Once I have it grouped, I'm going to count it. When you apply some aggregation like count or reduce, you're going to get a K table back. So from a K stream, you can go to a K table. So I'm going to just convert that into a stream again, so I can map it to a class called category count. Category count is basically getting the category, getting the count, and that's what we're going to send back into Kafka. And notice the send to annotation here is getting a case stream, and we're going to send it to the output binding. So the output binding is basically configured in here. So we go back to the configuration, we're saying that the output binding is called page counts. So what we're going to do is to basically read from the page view. We're going to run all the topology. So we're going to group, we're going to count, we're going to map, and the result will be sent to the page count topic. So we can try to start it. I'm going to stop the reader. I'm going to start this guy here. And in the meantime, I'm going to stop this aggregate, clear. And I'm going to start the page count. It's called counts. And this is the topic that we're going to send data back. All right, so let's try that. Let's interact with our e-commerce site. So as you see, right, so we're basically getting that category 1 has the count to 54, 57. So notice that we're skipping some records here. Actually, well, every time that we count, we're sending the data downstream to Kafka. But well, that's an aggregate, right? And actually, we have a buffer. So from time to time, we're going to commit this data. And actually, by default, I have set it to 1 second. So every second, we're going to commit downstream all the data. So apparently, I have been interacting with the site before. So this is basically an aggregate, right? So if I buy the book, I see that the count is 5, 7. The good thing about Kafka streams is that if I stop the application now and I restart it back, and we start interacting with the site again, let's say, well, this one here, again, we see that it recovers from the state, right? So that state that was stored inside the RocksDB database is maintained right into Kafka. So if we stop the application, that state will recover from that from Kafka, right? So it's not like in the previous case where if we had that manually, right, we couldn't recover from that state. Can we have a couple of minutes more? Okay, great. So let's make it a little bit more complicated, right? And now I'm going to window, right, this data because I don't want to get the count for as a global count. I'm going to basically have it windowed. So I have introduced this window by here. So every 30 seconds, I'm going to close the window. So I want to get the count for every single 30 seconds. So I'm going to start that again, restart it. I'm going to basically and I'm going to interact with this site again. Okay, I'm going to start. So as you see, right, from down here, can you see that from here? We have actually a category count for the category 1, and I have here a window of 30 seconds. So I'm actually counting for 30 seconds. Let me just put that up a little bit so you can see it. So if I interact with the site again, I'm going to get, see the count? It has kind of restarted because that's another window, right? So the previous window was from 1519 to 00 to 1519:30. So now we are in another window. So we see that for this window, the count is 3. But notice that inside the window, we're still getting a bunch of messages. We're not getting the final result of a window. We're basically getting all the intermediate messages. All right, so how can we prevent that? We can prevent that by using something called suppression. So now we're going to define, apart from this, that we want the window to suppress intermediate records. So I just want to get the final value. I don't want to get all the intermediate values. I just want to let the window finish and then emit the record. And this is called suppression. This is a really nice feature if you just want to get one value at the end of the window. I'm just going to, 10 seconds. Okay. Notice that I've also defined something called grace, right? So which is the grace period. So what happens if we have a late arrival into Kafka? So you have a window. You have a late arrival at the end of the window, which is not in the window itself. We basically have to take this record and compute it in the same window. So grace is basically the amount of time we can wait to get these late arrivals. Now I don't want to wait for these late arrivals. So this is basically how we suppress intermediate records. So if we go back in here, we're going to interact with our site. Oh, there's something wrong, so maybe I'll have to check that. So let's move into the next demo because I have just 30 seconds, right? And the last demo is about joining, right? The different streams. So let me just change the binding real quick. So just because we have just 1 minute left, I'm just going to go real quick with that. But notice that our stream listener now is getting a bunch of inputs. It's getting one input, which is a case stream, and another input, which is a K table. So the count here was really nice, but wouldn't it be easier for us to read it if the category was like the name of the category instead of the ID? So I have actually another table which contains all the products and the category names. So what I'm going to do is to join two streams. One will contain the page views, the other one will contain the products. So when I join them, I can actually get the name of the category, right, and display the name of the category instead of a one here. So I have simplified a little bit the example here, but we see that the page views, which is the original K stream coming right from Kafka, is actually joined by the categories table, which is this one up here. And we have this value joiner. It's basically how we are joining both records. So basically I'm taking the page view from the initial stream, I'm setting the category name coming from the product, and I'm returning the same page view. So I'm going to group everything, we're going to count, we're going to stream, and map it back to Kafka. So if we restart that again, and we start interacting with, well, we see that here, right? So now the category is the name of it, electronics, because we had a join, right? So we had the page view, we joined with the product, we took the name of the category, and now we see that every time that we click in here, we get that. So if we click the books, we get the books, right? So we basically, we don't have windowing now, right? But we get the aggregate of all the messages. That's basically right what Kafka streams can provide, right? So it's basically a really nice DSL that allows you to process the data, right, with the stateful and stateless operations, fault tolerant, scalable. You can scale that, right, to multiple threads, multiple processes, and this will basically process a bunch of data inside topics, right? So based on the partitions you have, right? But it's actually the best way, right, to basically process those events and to deal with stream processing. All right. Okay, so with that, I think that we have to wrap up. So, well, thank you very much for coming. If you have any questions, I'll be here, right? And so I'll be happy to take any questions. I think that we have to stop the recording now, but I'll be here, so you can come to me and ask any questions. And also, if you want any stickers, Kafka stickers, come to me as well, right? And I'll just give it to you. Right? So thank you very much.